Modern railroads are constructed by welding easy-to-transport 40-foot sections of rail into smooth, uninterrupted ribbons, often right on the job site. At the Union Depot, the longest sections will stretch nearly 1,000 feet, and despite weighing over 45 pounds per foot, steel rail in these lengths can be curved and manipulated as needed.
Our responsibility is to construct this track in a timely fashion and safely. Right now we're doing flash butt welding.
Flash butt welded ribbon rail reduces both wheel and track wear. It creates a smoother and quieter ride, eliminating the clickety-clack traditionally caused when track joints were only 39 feet apart.
We start feeding the rail on the end down there. Then the rail is polished on both sides for the contacts.
A newly cleaned contact area is needed because as each weld is made, over 300,000 watts of electricity will flow through the rail.
Then it comes down the conveyor, it goes underneath the welder. The welder will clamp onto it, hold it together, and then it starts at 200 volts of electricity through there, steps to 400, then to 600. It physically melts the end of the rail and squishes together and then shears the excess off. And then when that is done, the welds move down to the next station where the base is ground and some polishing on the sides. Then it moves down to one more station to the finished grind. They'll polish it up and that's it. And then we'll lay out our ties, plate, high spike, and then we'll thread our rail up on the ties and spike it up.
Welding rail already in place doesn't require the massive ribbon welding equipment used initially. In fact, it can be done very simply using a process dating back to the late 19th century, thermite welding.
Well, you set your rail up and you have a 1-inch gap in your rail. You line your rail up, your base, and put a slight crown in the rail. Then there's a base plate that goes on, it's sand, and 2 side molds that are sand, and they're clamped on there. And then you preheat the rail, and when you get to your preheated temp, you'll put your crucible charge on top and light it. And then it flows into the weld.
Inside the crucible is a powdered mixture of aluminum and iron oxide. In a matter of seconds, the reaction reaches over 3,000 degrees. The molten steel flows into the mold, welding the rails together as waste overflows into the slag pan. The mold is then removed. Excess material is broken away as the joint is allowed to cool. When ready, the new weld is smoothed and ground to the proper contour. Once the rails are welded and in place, crushed stone ballast is spread on the track. When packed carefully around and below the ties, the ballast will stabilize, support, and cushion the track structure under the enormous weight of passing trains. Ballast compaction and final rail alignment are done simultaneously with a tamping machine. First, optimal track positioning measurements are carefully confirmed. Then, a laser emitter is placed far down the track. Once aligned, its beam will allow a fixed point of reference as the tamper does its work. A set of 3 lights, red for too far left or right and white for center, tells the operator when the beam is precisely aligned. Once underway, the tamper moves methodically along the track. It is a long machine with its weight resting on the rails only at each end. This allows hydraulic jacks to actually lift the track under the middle of the tamper, correcting alignment and height as it does so. To maintain this new position, metal fingers firmly pack or tamp the ballast under and around the ties. Depending on the amount of repositioning needed, the tamper may make several passes over the same stretch of track.